Alright, for this question, we are having it that what volume of hydrogen gas is produced at 27 degrees Celsius and 680 millimeter mercury when 3.25 grams of zinc reacts with excess diluted hydrochloric acid. Now this question comes by combining two topics together. The first topic that this question brings with it is Moleconcept. The second topic that this question brings with it is ideal gas equation or ideal gas law. Without wasting much time, let's go into the calculation. Now the question says, what volume of hydrogen gas? So volume is not known. Alright, it's produced at 27 degrees Celsius. So temperature is given at 27 degrees Celsius. And don't forget, we need to convert to Kelvin by adding 273. So we have 27 plus 273. If we add this, we are going to get 300 Kelvin. So we have this. Alright, furthermore, and 680 millimeter mercury. So we have pressure to be 680 millimeter mercury. So we have this. Alright, the last thing we need, remember, we are dealing with ideal gas equation. So we are given the molar gas constant here. So we need the ideal gas equation, which is PV equal to nRC. Alright, now pressure is given at 680. Volume is not given. Number of mole is not given. Molar gas constant is given. Temperature is given. So we need to look for the number of mole. And that is the reason why for giving us this chemical equation. So we need to use this chemical equation to derive our number of mole. So how do we go about that? The question says that what volume of hydrogen gas is produced at 27 degrees Celsius and 680 millimeter mercury when 3.25 grams of zinc. So as we can see that we are having zinc having value to be 3.25, and we can see that all these questions here are depending on hydrogen. So we can deduce that the question is talking about zinc and hydrogen. Alright, let's bring out the zinc and hydrogen. So we have zinc relating with hydrogen. So we have hydrogen. We are having mass for zinc and we need mole for hydrogen. The standard mass for zinc is 65 grams. Now, if 65 grams react with hydrochloric acid, 1 mole of hydrogen gas is produced. So we have 1 mole produced. Here now, we are having 3.25 grams of zinc reacting with hydrochloric acid. From here, when zinc reacts with hydrochloric acid, 1 mole is produced. Or let me say that when 65 grams of zinc reacts with hydrochloric acid, 1 mole is produced. When 3.25 grams of zinc reacts with hydrogen, how many mole will be produced? From there, we can get our number of mole. how many mole we produce? How many mole will be produced when 3.25 gram of zinc, reacts with hydrochloric acid? So we have this. If you cross multiply, we are going to get x times 65 equal to 1 times 3.25. The next thing to divide by 65. So we have 65 over 65. 65 here 1, 65 here 1. We have x equal to x times 1 divided by 1. We have x. 1.1 times 3.25 divided by 65. We are going to get 0.05 mole. So we have this. Our number of mole is gotten to be 0.05 mole. We have this. We have this here. With this, we can now proceed with our calculation. But let's not forget something. Notice something. In the question, we are given our pressure in millimeter mercury, but we are given our molar gas constant in atmosphere. Like I said earlier, in the part 1 of this video, you can check it out. I said that if we have millimeter mercury here, or let me say if we have two different value for pressure, or let me say different units for pressure, we need to convert. In the previous videos, we have the same pressure being given, but in this question, we are having different units of pressures. So what do? We need to convert either of the two to fit into the same unit. For this question here, I would like to convert this 680 millimeter mercury to atmosphere. And in other ways, you can use the molar gas constant that has to do with millimeter mercury. I derived that in my previous video on ideal gas law. You can check that out. So for this video lesson, I'm going to convert this to atmosphere. You can use the molar gas constant value here that involves millimeter mercury. You will still get the same answer. So I would like you to do that in your own calculation. Make use of the molar gas constant that has to do with millimeter mercury and give me your answer in the comment section. For this question, I'm going to convert this to atmosphere. So we have this. All I need to do is to 1 atmosphere is 760 millimeter mercury. How many atmosphere will be 680 millimeter mercury? I will have this. If I cross multiply, I'm going to get x equal to 680 multiplied by 1 over 760. So my x equal to, when we divide this, we are going to get 0.895 atmosphere. 0.895 atmosphere. So we have this. My value here now becomes 0.895 atmosphere. I have this. I continue with my calculation. PV equal to nRT. I'm looking for volume, so what do? Divide both sides by the coefficient of volume, which is pressure. Over pressure, over pressure. Pressure cancels pressure. Volume equal to nRT over P. Volume now equal to mole is 0.05. So we have 0.05 multiplied by molar gas constant is given to be 0.082 multiplied by temperature is given to be 300. Everything over pressure is given to be 0.895 atmosphere. Volume now equal to, we press our calculator, we are going to get 1.376 dm cube as our final answer. So we have this as our final answer. If you find this video helpful, do well to support this YouTube channel by hitting the like button so that this video can reach out to other people as well. Drop a comment, subscribe, and see you in the next video lesson. This is Olagold Academy. Thank you.